right? The magnitude of the couple is 50 Newton meters, and there is going to be a difference that we'll see in the end. So the scalar magnitude is 50 Newton meters. So it's given that what I'm going to call C, the magnitude of that is 50, and this is, right, Newton meters. Because remember, we're in 3D, the couple, in 2D, the one we just did, the couple was just a scalar value. In 3D, the couple is going to be a vector value, because it will have ijk components probably. So the magnitude of that vector has a magnitude of 50 Newton meters. So that's given to us. We're going to have to use that a little bit later. So what we want to find is what is that scalar value F. So we're applying this force equal and opposite on each of our wrenches that's going to create a couple. That couple has a magnitude of 50 Newton meters, so we have to find F such that this is true. And we have the diagram as well. So we only have, in this case, one pair of forces to worry about instead of the three we had in the last example. So one of them is acting here, downward on this point. Instead of drawing this whole assembly here, it really doesn't matter that there are pipes and wrenches. All we really need are coordinates for this thing to work out for us. So I'm going to say that this is acting on a point I'm going to call A for convenience. And I'll just put the coordinates of A rather than trying to draw the pipe and the wrenches, which again don't really matter for what we're analyzing here. So point A is going to be located at, in the x direction, we have to go 200 millimeters. In the y direction, we have to go 300 millimeters. And it's in the xy plane, so 0 in the z direction. Now it'll be in millimeters. And then our other force is being applied somewhere over here at a point that I will call B. And that force is acting in the positive z or the positive k direction. So they are going to have the same magnitude F, but different directions. This is negative k, this is positive k. So this does form a couple. And point B, I want to put its coordinates down here. So in the x direction, to get to point B, I have to go 300 in the x direction, millimeters. And I have to go 300, 600, 800 in the y direction. And it is also located on the xy plane, so 0 in the z. All right, so I have my coordinates, I have the forces. This is enough for the diagram so that I'm going to be able to, in the next step, get our, find the couple. All right, so we know that the couple, the magnitude of the couple due to just this pair of forces has a magnitude of 50 Newton meters. Before we get to talk about the magnitude, we first want to find out what is the equivalent couple due to these two forces. All right, so we can find the couple by using, since we're in 3D, I want to use the cross product to do this. This is where we have to be a little bit, or we have two choices to make of what are we going to use for R, what are we going to use for F. So the choices are going to be, I can use either this force or this force as the F in the R cross F. They have the same magnitude, but their directions are different, so they are going to be different in the cross product. Let's just say I want to use, what should I use in my notes? I used this one in my notes, but I could have also used this one. If I want to use this F, this F is in the K direction. If I wanted to use this F, this would be cross F times negative K. And then there'll be that would also change which R vector I want to use. So for my notes, what I want to use here is if I'm using this F, I have to use the position vector that starts at the other force and ends at the force I'm using in my cross product. So in this case, I would use the R that goes from A to B. But again, I could use the other force, which is going to be in the negative K direction. But in that case, I want to start at the other force, and then go to the force that's in the negative k. The end result will be the same because RAB is the same as negative RBA. F and negative F are the opposite. So this would have two negative signs that would cancel each other out and be the same as just doing this. So again, they're equal to each other, but I don't want to mix the two together. I don't want to use RAB cross negative F, or I don't want to use RBA cross positive F. Either both of them here or both of them here. All right, so in my notes, I just used the first one, but yeah, I would get the same answer either way. And these should be, vectors. All right, so working from the left-hand side here, my position vector, RAB, is going to be the coordinates of B minus the coordinates of A. So that'll be 300 minus 200 is 100 millimeters in the I direction. 800 minus 300 is 500 in the J, and 0 in the K. And for my vector F, I don't know its magnitude, but I do know its direction. I know that it has nothing in the I, nothing in the J, and all of its magnitude F is in the K direction. So in this case, I do have an unknown value in my cross product, but that's okay because I know how to expand the 3x3 determinant. And this will be measured in newtons because our answer eventually should be in Newton meters. I expand this out just like I have before. So I'm going to get that the value is 500F in the I direction minus 100F in the J, and then no K component here. So this is the equivalent couple due to this pair of forces acting in the positive and negative K directions. So where do I go next to find my value for F? This is C, the vector C, so there's kind of one more step between them. Because, again, the magnitude of this we know, so we have to find what the magnitude is. So the magnitude of this is I'm going to take quantity 500F squared plus quantity 100F squared. Right? Just like we found magnitudes of forces or position vectors, we want to take the sum of the squares of all of their components. And if we simplify that out, we get 510F. And again, I didn't change anything yet. That's in Newton millimeters. From the given, we know that our goal here was we want the magnitude of this couple to be 50 Newton meters, and that's now going to allow us to find the value of F. So this 510F, again, this is in Newton millimeters. I can either convert this now to Newton meters, or I can convert my 50 Newton meters into Newton millimeters. It's going to have the same difference. All right, so the 510F is equal to 50,000, and that's converting the 50 Newton meters into 50,000 Newton millimeters. At this point, magnitude of C equals the magnitude of C. The only thing I don't know is F. So in order for this to be true, the magnitude of the force at which I'm pushing on the wrenches is going to be 98 newtons. Right? Because this was millimeters, this was Newton millimeters, so F is going to be measured in newtons.